Hi everyone, this is Jonathan Marin and I'm student of the subject discrete maths. And in this presentation, I'm gonna show you a simple example of variations and combinations. Uh, that way you can understand easily what those concepts mean. But by moving to an example, we need to understand first the definition of each one of these concepts. So the first one is variations. When you can see, as the slide says, that is um, the calculation of different ways to order or accommodate a group of elements. In here, order matters. The opposite way to the combinations, where of course it's similar in the aspect of you can select some ways of choose a group of elements, but the order of the elements into those combinations doesn't matter. Okay, so you have some similarities in both of these concepts. The first one is that require a total set of elements. You need to have a set of the specific elements to make variations or combinations. Both require factorial for their formulas, and both of them serve to count possible selections or arrangements. Now, moving into the example, let's assume that you have four instruments and you want to make a musical track, right? And for that musical track specifically, you want to start with two of these instruments. The instruments that we have here are drums, guitar, saxophone, and the piano. Okay, so if you want to select two instruments to start with your musical track, you can have like this kind of combinations: guitar, drums, guitar and piano, guitar and saxophone, drums and piano, drums and saxophone, piano and saxophone. Because it doesn't matter the order that you're gonna have, you're gonna select. You can start with drums and then with the guitar, and it's gonna be the same way as if you start with the guitars and then with the drums, right? So you have the formula here that is combination of n and r. It's equal to n factorial divided by r factorial multiplied times n less r factorial, right? When n means the total of elements that you have into your set, and or the amount of elements that you're gonna select specifically into from that set of elements, right? Okay, so in here, order doesn't matter. So this is something simple, and you have the combinations here already explained. But what if you want to be a little bit more specific in the order that you're gonna be using for these elements to be implemented, right? So in that specific example, drums first and then guitar is not the same as guitar first and drums later, right? So besides the same combinations that you have from the previous example, you need to add some additional more because you have guitar drums, but guitar drums is not the same as drums and guitars, and guitar and piano is not the same as piano and guitar and saxophone is not the same as saxophone and guitar, and so on, right? So those are different examples, so you need to duplicate the amount of variations that you can have in here. So the formula for this um, concept is variation of n and r equals to n factorial divided by n less r factorial, where the n and r are the same elements that we have mentioned previously. So n represents the total of elements that we have from the set, and r represents the amount of elements that you're gonna be picking from that set of elements, right? So that's pretty much the example that I wanted to give you so you can understand easier the difference between combinations and variations. Thank you so much, and thank you to Slidesco for allowing me to use this slides draft for creating this presentation. Bye.